Alright guys, so here's an observation I'd like to share with you. Maybe you could help me out. This is a very common diagram for those of you that are doing the research. Basically, we have this is patent number 4936961. And it shows us the step charging effect and the sequential order of what happens to the water molecule as it breaks up. So first of all, he shows us what's called a repetitive pulse stream. So you have these pulses sequentially, and as they happen, the water charges and it builds up charge. As this happens, you start polarizing the water molecule. Eventually, you have an elongation of the water molecule. Then you have what's called the covalent breakup of the water molecule. Now, as this happens, the voltage peaks, then it falls, and it peaks, then it falls. So we have a pulse train. We have a charging effects, peaks, fractures, come back down again, and the process continues. And this is typical for all of his patents that we've seen as far as the VIC circuit of voltage intensifier. Now, this is something that caught my attention here. This is the Birth of New Technology book, written by Meyer. And one of the things that caught my attention was this page 337. We have a diagram here, electrical step charging effect. Once again, you have the repetitive pulse train, and as this happens, we can see the charging of the water. Something caught my attention, and is the explanation of Stan Meyers of this picture here. I'd like to share this with you guys. This is found in page 316. He says the following. It says, by attenuating the voltage amplitude, and that's VO through VN. Once again, we go back to the drawing to confirm that we're right where he's talking about. So there's VO through VN. Interesting. He's telling us that by us regulating this voltage here, we can change the output performance. Now, he says also in conjunction with the pulse width. So here's the pulse width, and there's the voltage amplitude. Now, I used to read this and just swing right by it real quick and not pay attention that he was referring to the voltage amplitude, not just the frequency. And this caught my attention because how can we vary the voltage amplitude if it's not, for example, in a variac, you can manually change the voltage amplitude, or if it's in a fixed scenario, there's really no way to move it up and down. I mean, you have a transformer, you attenuate it, but that's it. It stays at a certain level. I mean, the cell charges itself, and we hit the resonance, the cell will charge and fracture. But how can we attenuate this? So I kept doing a little more research, found this patent number. Here we go, 5149407. Now, this one is interesting because it shows the voltage amplitude. In this case, he's manually, once again, changing the voltage amplitude. How does he does this? Well, he has an SCR network, and they're tied into different voltage levels at the coil. So for this application, this is not to fracture the water. This is for the gas processor. But in this application is interesting because we can see, what he's talking about as far as how to monitor or control the voltage amplitude. So I was thinking, well, how can we do this electronically, where we can sequentially move up and down the voltage amplitude so that we can match the repetitive pulse stream? In other words, as we're going through this sequence, could we not increase the voltage as we're going through there and further enhance this polarization effect? So did a little bit of research and came up with this here. I'd like to show you. So here we have a sequential circuit, very simple circuit to hook up. Basically what we have is a 555 timer and a 4017 IC chip. It's kind of hiding in there. And In this case here, just for means of simplicity, I can show you here there's a variable potentiometer, and we can control the frequency. So you can see there. Now imagine that each one of these is a silicon controlled rectifier hooked up in a network like that. Now we can phase this correctly with a pulse train, and that would be a very interesting experiment. So let me show you how to connect that if you like to mimic it. Here's a sequential circuit. I found this online. There's multiple versions of this. There's a 4017. These are the outputs connected to the LEDs, and there's a 555 here, and then this is the control variable input. So let me know what you guys think about it. If you got any questions or you'd like to post any comments, please do so. Thank you.